Alright, okay, so today what we're looking at, guys, is we're looking at adding fractions that have the same denominator, and we've met this keyword before. The denominator is the number on the bottom, and we are going to also learn how to add fractions with different denominators. So firstly, we're going to start off by learning to add fractions that have the same denominator. So here's an example here. They have the same denominator, and then different ones would be something like this. So 1/5 plus 2/7. Okay, so the same denominator and the different denominators. Denominator just means the bottom number. Okay, so the first thing we're going to look at is like fractions, and these are have the same denominator. How can we add up the following sum? So we have 1/5 plus 2/5, and definitely how we first started doing this is by fraction charts. So I'm going to bring one into play here. Okay, so here I have a section that's been divided evenly into 5 segments, and therefore if each segment is even, each segment represents 1/5. And I'm asked, first of all, what would happen if I had 1/5 and I added on 2/5? So I'm going to use shading to show you this. So 1/5, that is 1/5 of that shape, plus 2/5, add on another 2/5, and that gives me 3/5. And so the rule is, if they have the same denominator or the same bottom number, you keep the same bottom number and you add the top numbers. So that's the rule. Keep the bottom number and just add the top numbers if you've got the same denominator. Alright, there's a few here we can practice and just make sure that we're able to do. So again, the same denominators, adding or subtracting, it's going to give you the same outlook. So I'm going to maintain the same denominator and just add the top, and 1 and 1 gives me 2. Here I'm going to have 2/7. 2 and 4 will give me 6, and I have the same number on the bottom, so that remains the same. Now I have 5/11 minus 4/11, so it's a minus, but it doesn't change what happens, okay? Add up fractions, add them together in the numerator and leave the bottom the same, and it's the same with subtraction. And so 5 minus 4 gives me 1, and 11 remains on the bottom, and 8/9 minus 5/9 will remain 4/9, okay? So, unfortunately, life is not always that easy, and sometimes we will be faced with unlike fractions, and this is when we have different denominators. Now, shading shapes is going to be a lot more difficult when I am unsure exactly what 1/5 of this shape is. I can definitely shade in 7/10. 1, 2, 3, 4, 5, 6, 7. That's what 7/10 looks like of this shape. But as regards adding in 1/5, it's going to be a little bit more difficult. And so I'm going to use my equivalent fraction method there just to see. So 1/5 is equal to something over 10. And what I do to the bottom is I multiply it by 2. So what I do to the top is I multiply that by 2. And 2 ones is 2. And I can now say that 1/5 is 2/10. So I can just fill in another 2/10. So 1/5 plus 7/9 is actually going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/10. But is there an easier way? And there is, and I'm going to show you that in the next slide. For unlike fractions, what we can do is we can find a common denominator. And common just means the same, and denominator, we've already met, is the bottom number. So we're looking to find the same bottom number for both of these. And it's very similar to the work that we did in ordering fractions. We're going to first of all find the lowest common multiple between 5 and 10. And the quicker we get at these, we might be able to spot them a little bit better. But just to, for argument's sake, we'll write them out. So for 5, we've got 5, 10, 15, 20. I'll stop there. And then for 10, we have 10, 20, 30. And so for me, the lowest common multiple I can see is 10 in both. Okay, so I can split it up into 2 ways like I've done before. So 1/5 is equal to something over 10, and 7/10 is equal to something over 10. And draw my line. And we looked at this way for comparing fractions, and it works perfectly fine for adding fractions, so why not stick with it? All right, so I asked myself, what do I do to 5 to get 10? And obviously it's going from a smaller number to a bigger number, so there's definitely multiplying here. And the answer is I multiply it by 2. And of course, what I do to the bottom number, I must do to the top. And so I'm asking myself, what is 1 multiplied by 2? And the answer is 2. And likewise, 10 multiplied by 1 will give me 10, so I'll keep the same on top. And I get 7 out of 10. All right, and now I have to, I suppose, tidy things up a little bit and actually do a bit of the sum. So I was asked what was 1/5 plus 7/10, and I know now, well, 1/5 is 2/10 plus 7/10, which is 7/10, and that gives me 9/10. All right, so exactly how we did with converting fractions with equivalent fractions, and the final step here is we're just adding our two answers together because we know ourselves we can add them quite easily if they have the same denominator. And so now that they have the same denominator, we can add them quite easily, keep the bottom number and just add the top. Okay, we'll try another example, and this is an example that is dealing with subtraction, but again our methods don't change. So suppose LCM in the corner, and I'm going to try and find the LCM of the two denominators here, which is 7 and 6. So hopefully I can learn my 7 times tables, or I remember them. 7, 14, 21, 28. So 7 ones are 7, 7 twos 14, 3s 21, 4s 28, 5s is 35, and 7 sixes are 42. And then I suppose we'll skip on to the 6s, and we have 6, 12, 18, 24, 30, 36, and the last one there is 42. I've spotted that the lowest common multiple is 42 in both of those. Could I have figured it out a little bit easier? Well, maybe in primary school you actually figured out that if you multiply the two bottom numbers here, you can get a common multiple between them. So that's also a method that works. All right, so no different now. 4 over 7 equals something over 42. And we've got 1 over 6, which is equal to something over 42. All right, so 7 watts give me 42, 7 sixes. And what I do to the bottom, I must do to the top. And 6 times 4 is 24. And then over here we have 6 multiplied by what gives me 42, 6 sevens are 42. What I do to the bottom, I must do to the top. And 7 ones will give me 7. So I now have given myself, I'm just going to make this a little smaller, I'm giving myself two sums, all right, that I have changed, that they have the same denominator. And once they have the same denominator, it's again much easier for me to do my maths. So it is 24 over 42 minus 7 over 42. And so this is the final step. This is just what we're looking at today. Bringing your two answers together and applying your maths. Well, whether it's adding or subtracting, if they have the same denominator, my answer will always have the same denominator. So I'm going to fill that in first. And then the top line is then just our normal operation. So 24 minus 7 is going to give me 17. Okay, all right. So that is the answer to example 2. Here a look at the keywords that we've met so far in today's lesson. Denominator, well, we've met that before, and more than likely you already met it in primary school. Like fractions and unlike fractions. Can you give me an example of what a like fraction is and what an unlike fraction is? Well, like fractions, we say that they are 1/5 plus 2/5. They have the same denominator. And then unlike fractions will not have the case. Addition and subtraction, be careful to watch your signs. A lot of people make mistakes in not looking at what the question is asking. LCM, we needed that to find what our common multiples, our denominators would be. And common denominator, denominator the bottom number, common means the same in both. All right, so your learning check for this evening is these 5 questions here. 1, 2, 3, 4, 5. Okay, make sure all of your work is nicely laid out. You've given yourself a date and a title for tonight's homework. And I'll see everybody tomorrow.